So, good evening, guys. Welcome to our session in here for today. I hope all of you guys are able to hear my voice clearly, right? Can I get a small confirmation, guys, for this? Whether my voice is audible, whether my screen is visible, and whether everything from the internet point of view is going good or not. Everybody, guys. Okay, thank you. So, a lot of learners, Vishnu has given me the confirmation. Okay, perfect. So thank you everybody. Thank you for the confirmation. I hope you guys are doing very well and let us get started. So one update I have for you now, we would not be having 1.5 hour session. Okay, there is a change in the curriculum. We would be having a 2 hour session on Wednesday and 2 hour session on Saturday, 5 to 7 p.m. both. Timings are same. Timings are not different. 5 to 7 p.m. Saturday and Wednesday and Saturday. Sorry. So this is basically something that I wanted you to be like kind of aware of. Okay. Another thing that I want all of you guys to understand, it is basically revolving around a section that we would be kind of moving ahead with what you can say with our coursework, right? That's available over here. So if I zoom into this particular portion, you guys can see that it is Introduction to Generative AI and ChatGPT. So this week, this first class Introduction to Generative AI, it's almost done, right? And this demystifying the ChatGPT one, this is the main aim for this particular week. So in this week, that's the plan, as I have told you, that we would be completing the generative AI today, first of all, in the first 15-20 minutes maybe, and then demystifying ChatGPT is something that we would be doing. So this would be having 6 hours in total. Okay, so let's get started without wasting any time. First of all, this is the document. This is the same document that I have shared with all of you guys in the earlier sessions as well, but I have added the content for ChatGPT at the end in this document. Okay, so you can go through this and let me know if you are having any questions or if you are having any doubts on this. Everybody, guys, right? So this is basically something that you are kind of expected to move ahead with, and let's get started with this. Okay, so we have already done introduction to this much part, right? Applications, what is the difference between machine learning, what is the difference between deep learning, what are the deep learning applications, NLP, reinforcement learning. Challenges are the data variability, computation resources, time consuming, interpretability. I is not in bold, I don't know why. So interpretability, overfitting, correct. So you can open this, all of this thing up in your own laptop and you can read over there as well. I will keep on explaining. And the same thing is written over here as well, right? So basically the first part is that for revision, I'm saying that the most important part, everybody please pay attention. The most important part for you, if you want to understand generative AI, you need to understand deep learning. Unless and until you guys are not having a strong knowledge of deep learning, you will not be able to cope up with the portion. Please remember this, everybody. Now, data availability, computational resources, time consuming, interpretability, overfitting, all of these things are there. I gave you this document earlier as well. Advantages are there. The most important advantage, see, this is underlined as well. High accuracy, scalability, all of these things are not underlined. Only the second point, automated feature engineering, is something that is underlined. And the reason why this particular portion is underlined over here is because of the fact that this is something which is a considerable advantage. So what has happened over here is that, okay, if your algorithm is having a very good what you can say performance, okay, we are happy about it. But other than this thing, other than this particular portion as well, there are a lot of important things that we need to kind of take into consideration, right? And out of which one of the primary things over here is that we need to kind of get an idea, or we need to kind of get an overview about the feature engineering part. So, see, in machine learning, the feature engineering part is manual, and the reason I mean, since it is what you can say automated, since this is like an automated way or automated fashion. So the more amount of data you feed, the more features it can try out, okay, on its own. And that's why as the amount of data increases, the predictive performance of deep learning algorithm also increases considerably, right? So that is a really important point. I mean, worth making the difference. Okay. Other than that, the disadvantage is that unless and until you give large amount of data, that too large amount of labeled data, you will not see any difference. Okay. So it needs a large amount of data. It needs high computational requirements. Interpretability is bad because a lot of people see that deep learning is like a black box, right? So this is basically something that all of you guys need to be aware of. Overfitting issue is there, black box nature. See, actually black box nature and overfitting, they're kind of intermingled. It's more or less similar point. But yeah, nevertheless, let's try to move ahead with the section. Let's try to move ahead with the portion. Okay. So now after this particular part, after this particular section is done, the next part over here that I want all of you guys to be aware of, it is basically revolving around the section that what is generative AI, right? Nowadays, like three, four things are really in great demand. Generative AI, chat GPT, chatbot creation, LLMs, right? These are some of the points or some of the things which are like in demand like anything, correct? So what is this chat GPT? Sorry, generative AI. Generative AI is basically something which is useful for generating something. So up till this particular moment, all the AI that was available, I mean all the ML algorithms and everything that was available, it was only useful for predictions. So you give the historical data, then there is training that you do, and then you are basically expected to move ahead with the next part, right? So that is basically something which you need to kind of understand. Are you getting my point, everybody, guys? Next thing over here is that you also need to understand that in generative AI, basically you can generate the data. Like if you go on chat GPT and if you ask that I need the code for this or I need the code for that, it will give you the code. So why do you think it is able to give you the code? Because it's generative AI. It is really useful for generating some information that is available over there, right? So that is like one of the prominent things, or that is like one of the prominent portions over here that you need to be aware of, correct? Now, after this is done, the next thing or the next portion over here with which you guys are expected to move ahead with, it's about the fact that there is data that you give, right? And what is the output of generative AI? Generative output of generative AI basically is revolving around the fact that it will generate the data. That's the part. So you will give the original data. You will tell the interpreter that this is how the original data was kind of looking. And based on that, it will really help you to get the new possible data that is available, right? So that is what it is all about, right? Now, after this particular section is done, right, the next thing that I want all of you guys to kind of understand, it is basically revolving around a section, or it is basically revolving around a portion that you need to be kind of aware of generative models. So GANs, generative adversarial neural network. GANs is like a really big thing now. So GANs have proven like a great portion over here. Like they have shown tremendous results within the last few years. Okay, so GANs is like one of the next big things over here that you are kind of expected to move ahead with. And then let's try to see what better can be done over here with that particular section, with that particular part. Correct. Now, after this is done, GANs or generative artificial neural networks, these GANs are basically kind of one of the really interactive things that are available over here. Now, after this is done, here I have given about GAN in detail. So out of the learners that are present over here, guys, do you know anything about GANs? Anyone? Anybody, guys? So GANs, what is happening is that let us say you give some data to generative adversarial network. There are two elements in GAN. I have written everything in detail, but still I'm explaining you because my philosophy is that once a learner is understanding something, then it is a very simple task for him or her to just read that thing. This is what I feel. So, what is GAN all about? So, GAN basically is like it has two things, generator and discriminator. So, what happens is that you will give the raw data to the GAN network, generative adversarial network. You will give the raw data. Okay, no problem. Given raw data is given. What after that? After that raw data has been given, what you will basically do is that you will basically focus on uh, the generator part, right? So the generator will try to learn the pattern in the data. Let's say we give the picture of XYZ, any celebrity. You can consider your favorite celebrity, your favorite hero, your favorite actress, anything. You can give the picture of that person. Okay. And then you can ask that generator to generate the images of that same person, right? But with different backgrounds. Let's say playing chess. Let's say walking in garden, right? And then the generator will try its level best to generate artificial data or synthetic data, right? Can I know what are the things that we should know to learn this course? So very good question, Anjana. My personal recommendation is that you should have some background of deep learning, right? Other than that, I think we are good to go. Background of deep learning and strong in mathematics. Like if you have completed engineering in any field, I think your mathematical background would be strong enough, calculus, derivation, integration. But deep learning is something that you should know. So you should know the basic terminologies in deep learning, what is neuron, uh, what is forward network, forward propagation, what is backward propagation, what is feed forward neural network, and things like that. Okay, now let's get started. So this is the first thing that I think all of you guys should know. Okay, now after this is done, the next thing is, as I was saying, that you will give the raw data, which is the original data, actual data. Generator will try to learn the pattern, or generator will try to learn the trends that are available in the data, and based on the trends or pattern that are available in the data, the generator will try to generate some data. And obviously the data that the generator will try to generate, it's artificial or it's synthetic data, right? After this is done, what will the model do? That generated data and the original data, both of them will go to discriminator. And then the work of the discriminator, as the name is suggested over here, the generator will generate a new sample where a generator will try to distinguish between artificial data and actual data. So let's say you take your own picture. Okay, let's say you take your own picture and you want your picture in a particular background. You ask the generative network to do it. Okay. So what happens is that as soon as the generator creates that image goes to the discriminator along with the original data. Now it is the job of the discriminator to find which is original, which is duplicate, or which is artificial. So what happens is that initially it is very simple for the discriminator, because in the initial few iterations, the network is not strong enough. Okay, the two networks are trained together, and the generator attempts to fool the discriminator into thinking that generated data is real. But initially, discriminator is smart enough, discriminator is able to distinguish between artificial data and uh, actual data. Initially, I'm saying. But later on, what basically happens is that the discriminator is kind of inefficient in what you can say bifurcating the actual data and the separated data. Right? Later on, it becomes a very difficult task for the generator and the discriminator to do the same things over here. And that is the actual reason why you need to take this particular portion into consideration. Correct? Now, after this is done, after you guys are clear with this section and after this is done, let us try to move ahead with the next section over here. So what I want all of you to kind of understand over here is that it is kind of your responsibility to be aware of these sections over here, right? So now after this is done, you read this much portion and you will understand that with few consecutive iterations later on, what basically happens is that the generator is not able to distinguish between a discriminator is not able to distinguish between actual data and generated data, and because of that particular part or because of that particular portion, the artificially created data is so well that there is no absolutely no problem with it, right? So take your time, go through this, and let me know if I can help you with anything over here, guys. So this is something which is used. So take your time, read this much portion. And by the way, any question, whatever I have mentioned over here, that same thing is in this two paragraphs. So take your time, read this, and let me know if I can help you with. So it is very important for you on an individual level to understand that how is the philosophy of generative AI, right? That is like kind of one of the most important things that you need to understand. So now after this particular section is completed, right? Let us try to move ahead with the next part. Okay. So how does the discriminator identify real and fake data? That's what is the main part. So the generator tries to identify that. We will understand it, right? So this is what is GAN all about. It is used for image synthesis, right? And all of these things over here. Now, after this is done, there is something which is called as generative, which is the generator model, right? Which is generating the artificial data. And what is this? It is generating the data in terms of probabilistic models, right? Now, after this is done, the next part over here is adversarial, right? What is adversarial? It is referring to setting one thing up against another. So what is happening is that the artificial data is superimposed on real data. And that is how this means that the generative result is compared with the actual images, and the discriminator then tells her, my friends want to pay and join for internship in the same program, so that they will get separate batch by which they will get from session one onward live, or else they want to watch record. I think for this, Ravni, you should get in touch with course coordinators rather than me, right? Okay, perfect. So now what I was saying is, what is adversarial networks? Adversarial means that they are being compared with each other, right? What is the meaning of that? That actual data and superficial data or generated data, it is basically something which is superimposed on top of each other, right? Now, what is happening is that the discriminator tries to find whether it is able to distinguish between artificial data or original data or not, and original data or not. And I mean, provided if it is being done, very good. Otherwise, you try to move ahead with the next part or next scenario, right? So that is basically one of the key points with which you are expected to work. And networks is that you will use neural networks for that. So take 30 seconds of your time, read this. What are the components of GAN? This is a very important part, by the way. Then we will move ahead with the next portion. So after this is done, yes, Sanjana, tell me. What is probabilistic model? Very good question. Probabilistic model is a model in which you get the probability of everything. Let's say you have created a model which is trying to classify whether the given email is spam or not. So it's not that it's always saying that this is spam, this is not. So it's just giving the probability of a given email being spam or not. So that's something which is coming under probabilistic models, right? That is basically something which is coming under probabilistic models, right? I hope this clarifies, Harika. Here you get the probability of data point belonging to the things. Now, after this is done, take 30 seconds to read this. According to me, this is one of the most important aspects. So if the discussion in an interview is going with this particular part, then I think you will definitely be in a position to get an idea or an overview about it. So could you please name a few examples of generative model? So it's not that there are like examples of machine learning model are random forest. So there is this generative model. You have to design that network. All the generative models come under this particular part. Other than that, examples of probabilistic model is logistic regression. Logistic regression is a probabilistic model. Knife Bayes algorithm is a probabilistic model, right? So these are the two examples of probabilistic models or probabilistic algorithms over here. Correct? Now let's try to get started with the next part over here, which is architecture of GAN. And this is the most important, or this is the core part of the given portion. Right? So GAN is composed of two parts, generated model and discriminated model. Right? So what is this generator model? Let me have a enter mark over here. So generator model is basically a key element responsible for creating fresh, accurate data in the generative adversarial network, right? So it is basically creating the new data or artificial data. It can be text, it can be PPTs, it can be images, it can be even code in your case, even queries in your case, right? And the training data's underlying distribution is captured by the layers. What it means is that whatever is the pattern of the input data, the neural network tries to capture that pattern. And by making some changes in those patterns, a very small, minute changes, new data is being generated. So generators' ability, or the better is the quality of the data created by the generator, the better it is. That's what it is all about. So try to read about this. This is the philosophy behind the generator model. And again, one of the most important things over here. Now, after that is done, there should be some statistical measure through which you are measuring, I mean, some formula through which you are measuring how efficiently the work has been done. So what I meant by that is that even if you are attending the session, right? Still, you can see that in schools, colleges, everywhere there is a way that they come out of to evaluate the predictive performance with, right? To evaluate how the people have worked, correct? So that is basically something which I want all of you guys to kind of understand, correct? Now, after this is done, the next part over here is generator loss. The objective of the generator in a GAN is to produce synthetic samples or synthetic new data, as we know, right? And to fool the discriminator, or and what is the meaning of fool the discriminator? Fool the discriminator basically means that as multiple iterations of generator and discriminator would be running, you will get an idea, right, about this particular part over here, correct? So what happens is that this is the cost function, which is the minus 1 by n, right? Means negative average of log of this log of probability of discriminator being correct for generated samples. So basically what is happening is that cost function should be minimum, right? And log of this, so for cost function should be minimum, log of this should be close to 1, then only it is minimum, right? So this is basically something that you guys need to kind of work around. Take a minute, read it. M is the number of data points. Everything is mentioned over here, right? So this is something that will also give you the mathematical background behind generator model, right? So there are two components, generator model, discriminator model, and this will give you the mathematical background behind this. 30 seconds, everybody guys on this. Now, after this is done, yes, Dilip, tell me. Any questions, Dilip? Any questions on this, Dilip? What is the method of fooling? Exactly, very good question. Hemant is having a question, guys. What is the meaning of fooling a discriminator? Fooling a discriminator means that there is original data. Generator is creating artificial data. So let's try to understand it over here, right? So there is actual data that we are going to give, right? This is actual data. This is generated data. So what is fooling the discriminator meaning? Fooling the discriminator means that this is mixed, actual data and generated data. And then we try to see that is the generator able to identify these two things or not, right? Is the generator able to identify these two things or not? So that is what is the meaning of this particular portion. Is it clear, everybody, guys, to all of you? What is the meaning of fooling the discriminator? Hemant, you are clear on this? So actual data plus original data, it is mixed. And then we ask the discriminator, you tell which is actual and which is duplicate. And if that discriminator is able to do this thing, good, well and good, right? So take your time, go through this. Now, after this is done, let us try to move ahead. What is loss? What loss may occur, sir? Loss is basically the concept of loss function is something that you get from deep learning. And the concept of loss function is the miscommunication error that is present in the model, misclassification error. So in simple words, higher is the loss, greater is the errors that are present in the model. In very, very simple words, right? Higher is the loss, higher is the error. That is like what you have to understand. Right? Everybody, guys, are you clear with this? So now let's try to move forward, right? Let us try to move forward. And let us try to see the discriminator's perspective. Sir, again, next session is on Saturday. Yes, Ravi. So now this is the discriminator model. And as you guys know, in the discriminator model, what is basically happening? So in the discriminator model, a artificial neural network, right, is created, or a neural network is created in short, right? And that is basically giving you the difference between actual data and generated data, right? That is what it basically means in very simple words. Correct? So now after this is done, go through this part. So different trying to differentiate between actual data, differentiate data, increase the so up till discriminator loss, you try to read, right? You try to read the discriminator model. I have given you information about this. Then we will try to see the mathematical background behind this. Now, after this is done, take 30 seconds, read it. And now there is one comment in the global chat. Can you share the document again? Why not? This document is something that I have prepared for you guys itself. Yes. So this is the document. My suggestion, even I said this to all of you guys in the last session, even today I'm sharing, saying the same thing. If possible, please try to make sure that all of you guys are in a particular position over here, right? And now after this is done, let's try to see the discriminator loss. So we also have to measure the performance of discriminator. So this is the second part, convolutional layers, pertinent structures, everything is identified, and we are maximizing the discriminator's capacity to accurately identify. The better your discriminator works, the better your generator will have to work, okay, so that you get started with creating better quality of images. And this is the loss function of the discriminator. Again, The higher is the value of loss function, the poorer your generated images are. It is negative likelihood of log of corrected probabilities. It's also the binary cross entropy in logistic regression. So if you have background, that is why I told you, if you have a background of data science and machine learning, it is definitely going to help you. So what I meant by that is that this is something which is going to really help you guys. Now, after this is done, after you have read this particular part or this particular portion, the next is this is the diagrammatical representation. So, latent random variable, generator, real data samples, and generated fake samples, they are mixed, and the discriminator is it correct? So, depending on this, so your discriminator's performance is very important along with your generator's performance. So when both of these two things are kind of working hand in hand, then at that particular point of time, you will get a very good overview about this part or about this topic. Correct? So this is basically something that you need to take into consideration. Now, after this is done, let us try to move ahead with the next section over here. So what is basically happening over here, that how is the GAN working? This is the workflow of GAN. So two neural networks are created. One is generator, another one is discriminator, right? And after this generator and discriminator are created, then you are kind of expected. G is the task of G is to create new data. Task of D is to critique the data and identify whether it is real or fake. So generator's first move means that G adds a random noise vector as input, right? This noise vector contains random values and acts as the starting point, and then the G transforms that noise vector, which is randomly initialized, into a generated image. So basically, the second point means that there is random initialization, and then with consecutive iterations, right? What is basically happening over here is that you kind of get an idea, you kind of get an overview that which one is working according to the expectations and which is not. So take your time, go through this, and let me know if you guys are kind of having any questions or doubts on this. Generators first move, okay? That is one of the most important things that you are expected to work around. Now, after this is done, the next part is the discriminator's turn, where the discriminator is the example generated by G in the previous step. They are analyzed and determined whether it is fake or not. So, 0 is that on a scale of 0 to 1. Score of 1 indicates it's real, 0 indicates it's fake. So, the the correct performance that it is doing, it's going to definitely have an impact, right? And that is what we need to identify over here. Take a minute for this, guys. Third point, this one. And now after this is done, if the generative model takes noise as the input, it will similar to which is not preferred exactly. And that is why in the first iteration, absolutely correct. That is why in the first iteration, it is not doing perfect job, right? So if you're feeling that in the first iteration itself, it's doing perfect job, it's not like that. But then with each consecutive iteration, it is going to do that thing, right? So that is basically something that you need to kind of understand. Now, after this is done, there is something which is called as learning process. So this is the adversarial part. So if D correctly identifies real as real and fake as fake, then G and D are being given us rewarded to a small degree because they are doing their jobs well. The key is to improve continuously. So it's not that in first iteration they will do the best thing. Okay. But the concept is that with each consecutive iterations, they will help you to get an idea about the part. And now there is a message in the global chat. Okay, understood. Thank you. Now, after that is done, the thing is that as the generative and D mistakenly labels G's creation as real, that is where you have your generator has done really good thing. That's a point which is worth thinking. Because what happens in that part is that your generator has created such a good amount of what you can say real data that the discriminator is not able to distinguish between generator and discriminator, and that's what's the good part. That is what is the good part. And now after that is done, if G correctly identifies G's fake data, then G is not receiving any reward and D is further strengthened in its discrimination abilities, right? So our aim is that by the end of the model training process, the generator should create such a good amount of data that the discriminator is totally confused that which is real and which is fake. Right? So that is what our main aim is. And after you have read this, is it really? No, it's not related to reinforcement learning. These two are totally different things. Right, so let us take a small break and guys, we will resume at 18:15 with the next part. Right? Thank you everybody guys. 18:15. Thank you. So let us get started with the session, guys. Right, I'm late by 2 minutes. No, meeting has not ended. I was late by a minute. Break time, yes. So let's get started with the session. Now there is another topic in your course curriculum called as VAE, Generative A, Adversarial Networks is done. There is VAE, Variational Autoencoders. So what has happened over there in this particular topic is, like as compared to GANs, in this particular part, the approach is slightly different. So what is different in this particular approach? The difference is the input data, right? It transforms the input data into newly generated data by process of encoding and decoding. So there is a transformer architecture over here. So the encoder transforms input data into a lower dimensional space, whereas decoder constructs it back to the original space. So it's kind of like this. Give me a minute. Let's say that this is a high dimensional data, and if you have to send that data through servers, so it is being transformed to a lower dimensional space with encoder, and then through decoder you again generate the raw data back. This and this are same, right? This and this are exactly same. So this is called as encoder architecture, and this is called as decoder architecture. So that's what is mentioned over here. So it is used to generate, again, like generative AI, it is used to generate data that resembles autoencoders, have the architecture that is used for the representation, and we are going to explore the architecture and foundational concepts of VAE over here, right? So there is neural network for encoder, there is neural network for decoder. The encoder aims to learn efficient data encoding from the data set and pass to the bottleneck architecture. So this portion is something that you can read. I've already given you an overview, but you can still read this 30 seconds, all of you, and then we can move ahead with the next part. Now, after this is done, the next thing over here that all of you guys are expected to move ahead with is variational autoencoder. It was proposed in 2013 by this scientist, right? Uh, that trick was at Google, Maxwelling was at Qualcomm, and it provides a probabilistic manner of describing the observation in the latent space. Your homework is to find out what is the exact meaning of latent space. So let's say I'm your interviewer and I'm asking you to describe what is latent space. You should be in a position to explain that. Right, everybody, guys, are you clear with this? Right? So the thing is, rather than building an encoder that outputs a single value to describe each latent attribute, we will have an encoder to describe the probabilistic distribution, and synthetic data generation, data compression can be effectively done, noise removal can be effectively done with the help of this particular part, right? So take 30 seconds, then we will go through the architecture of variation encoder method, this encoder, then decoder architecture. That's the next thing. 30 more seconds. What is variational encoder? You can read it in the document. Now, after this is done, the next thing over here is that what is architecture of variational encoder, autoencoder method. So basically what is happening is that here there are two things. Encoder takes the raw data, transforms it into probabilistic distribution of the latent space, meaning that for every attribute there is a probabilistic distribution. After that, the latent code generated by the encoder is probabilistic encoding because there is probability associated with all the things, allowing the VAE to express not just a single point, but like a lot of representations. So basically what is happening over here is that whatever is the latent space, in that latent space, you are basically trying to encode the data with a probabilistic outcome, probabilistic distribution. And after that is done, the decoder takes the sample point from the latent distribution and constructs the original data or the actual data back again. So the thing is that the disparity between input data and decoded output, it should be minimum. That's the goal. So whatever is the actual data and whatever output has been decoded, if that is having minimal amount of error, then your decoder is working, encoder decoder's architecture is working very well. Is it making sense? Is it making sense, guys, to all of you? Now, after this is done, yes, I will repeat it again, no problem, Shiva. So basically what is happening is that in VAE, there is a encoder-decoder architecture. What is the work of encoder? Encoder, as the name is suggesting, it is encoding the data into probabilistic distribution in the given latent space. Correct? So, and then from that probabilistic distribution, the decoder is trying to get the actual data back. So whatever the data is being given back, that data and this data, it should be as close to each other as possible. Correct, guys? So that is what Shiva is, this is third 3 points are all about. So you go through the 3 points and let me know you are having any questions on this. So now after this is done, the next part is that the process involves two critical components. First is reconstruction loss and second is regularization term. So reconstruction loss, what is this part? It is basically compelling the model to accurately reconstruct the input, whereas regularization is expecting, right, or it is encouraging this particular part in preventing overfitting. Regularization is always for preventing overfitting, correct? Now, after this is done, right, after this is done, after this portion is done, the next part is that by iteratively adjusting the parameters, the VA is in a position where we can kind of try to move ahead with the next part, correct? Thirty seconds on this, then we will see the diagram. If you know the theory, then the diagram is a simple cakewalk for all of you guys. Now, after this is done, so let's try to move ahead with this part, with the diagram. So this is the input high dimensional. It is being transformed into A1, A2, A3, A4, right? This is the lower Latin distribution, this is the variance. Then from that lower Latin distribution, samples are being created from which you again try to get back A1, E2, E3, E4, A1, E2, E3, E4, and then the actual data. So that is the main idea behind variational encoders, and the ideology is that lesser is the difference between the features, the better your model is. Like that's the simple ideology that is being kind of followed over here. Now, after this is done, the next part over here is about autoregressive models. So in generative AI, autoregressive models are used, and I have given a very short description because this topic was not there in great detail. So it is autoregressive models are basically a type of generative model that it's a generative AI model in which you try to create the data which has sequences like time series data, text, music. So let's say that you want to predict the price of a particular stock. So stock price is time dependent, right? And that is why you can use this autoregressive models over here. So this is something which is really important. You take a minute, you go through this, and then we can move ahead with the next part. So now after you have read this particular portion, I can send a document link. Yes, why not? I have already sent it, but okay, no problem. I will resend it. This is the document link again and again. I'm saying, please try to make a copy of this document in your own Google Drive or in your laptop. So tomorrow, if my OneDrive gets clogged up, right, then you should have a copy of these things in here as well. Correct? Now, after this is done, the next thing over here with which you guys are kind of expected to move ahead with is transformers. So transformers have basically transformed generative AI by introducing a highly effective architecture for tasks like language translation, text generation, GPT series, and even image synthesis. Transformers are again one thing. So ChatGPT, LLM, generative AI, chatbot creation, VAE, right? And transformer. Transformer is the last big topic over here. So even in transformer, there is a encoder decoder structure. You guys now know what is encoder decoder architecture. So encoder, as you guys know, has the work of encoding the data into a probability distribution in the latent space. Okay, then decoder is having the responsibility of getting that sequence back, right? So you take a minute to go through this, and then we will move ahead with the next part over here. And now after this is done, there is multi-headed attention concept, right? So you can ignore this as of now. This is slightly complex concept. It is basically used to capture dependencies between two text. So this is a sentence, right? In this sentence, there is a dependency of first word, second word, and everything because of the syntax, right? So that is why what is happening over here is that to capture that sequence, different aspects of the sequence, like parts of the speech tagging and everything, this model is something which is used over here. Correct? Now, after this is done, there is something which is called as positional encodings again for word embeddings, transformer decoder architecture. This you can read, it's for self-reading. Examples of generative AI where it is being used, you can read again this thing, it is for your homework. And then let's come to the main tools like ChatGPT, Google Bard, and Dolly. ChatGPT, by the way, is the most famous one, which I think all of you guys might have even used. But still, as a mentor, it's my responsibility to tell you about this. This is the link for ChatGPT. So basically, when you're going in ChatGPT, you are having options. So there are, first of all, two versions. I'm using the free version, right? But there is a paid version of $20, right? And business people can also have it $25 for the team, complete team. So let's say you are working at XYZ company. So there is an extension at the rate xyz.com. So for the complete team, they can have it in $25, which is a very good option. Now the thing is, the paid version is far better, right? I have a paid version in my company laptop, and here you can interact. So you can actually interact with ChatGPT like your friend. And now they are having a lot of other things over here as well. So I think it's not difficult for you to get an idea about this. This is chatgpt.com, this URL, and you can literally even ask answers for code. So let me give you an example of how powerful is the ChatGPT. Let's say you want to practice SQL, hypothetically saying. You are going on lead coding. Okay. And let's say that there is one problem of lead coding that you are not able to do. Let's stop this hard one. So you can literally copy this content, okay, paste it over here, and ChatGPT can give you the query. I've literally copied that problem, okay, and basically SQL is see they are explaining even the details. See, to solve this problem, we need to find the employees who are the high earners, then step-by-step guide, then this is the total query. And even the explanation of that query is coming afterwards. And in how many seconds we were able to get it, guys? 4 5 seconds, not more than that. Correct, everybody? Yes or no? Guys, you're there? Hello? Everybody? Yes, no. So within like 5 seconds, you got the solution for the hard level lead coding problem, right? So nowadays, that's how the coding is changing. Dynamic programming, competitive programming. Who will spend such a hard, such like at least 15 20 minutes debugging the problem and everything? You can get it in 5 seconds by chat. Best books for finance. Five best books for finance. Okay. So here they will give the, now the next is crux of this. So in a simple description, value investing, see, I don't need to read these books. I'm just seeing margin of safety, Mr. Market, value investing. Who will read that book? I took the top 5 books. I'm reading the crux or the gist of that book. Done. That's it. Are you getting my point? You don't need to read these many books. That's it. This much portion can do the work. That's the power of ChatGPT, right? So there are endless uses. Like there is no limit to the use of this ChatGPT and everything. So it's an NLP driven tool. It allows you to communicate like humans, correct? And this is something you can read. What is Google Bard, Dolly, and then there is a comparison. This is very important. Then there is a comparison of generative AI versus normal AI. So generative AI is to generate the data, whereas AI is used for prediction, uh, uh, clustering, anything. It's not AI is the general term, and generative AI absolutely is a subset of this part. Its application is in art creation, text creation, video creation, whereas it is in data analysis, predictions, automations, learning, uses of unsupervised learning, reinforcement learning, can use unsupervised and supervised reinforcement learning, output, complexity, data requirement, right? So you read this generative AI versus the normal AI in your own laptop for 2 minutes, right? In your own laptop for 2 minutes. Another message is over here. Attendance link, I think the course coordinators will let you know.